Okay, we're going to be working on a specific heat capacity lab. So this is going to give you an idea of what is actually going on in that lab. So basically what we're going to have in our lab is we're going to have a styrofoam cup, and that's going to be our calorimeter. Calorimeter is a calorie measuring device, and in that we are going to have some cold water. In a separate beaker, we're going to have some boiling water, and inside that there's going to be some chunks of metal. Okay, so the chunk of metal is going to come into thermal equilibrium with the hot water. So the temperature of the water here is going to be the same as the starting temperature of the metal. And basically what we're going to do is we're going to take that hot piece of metal and we are going to plop it into our cold water. And what we're trying to find out is the specific heat capacity of the metal. So this is hot, our water is cold, and so we're going to know its temperature too. Known starting temperature, so we know the starting temperature of both the metal and the water. Okay, and since heat flows from the hot to the cold, the metal is going to give off heat to the water. And what we said before is conservation of energy. The heat lost by the metal is going to equal the heat gained by the water. So, and remember, if we lose heat, it's negative. So we're going to use this idea to calculate the heat capacity of the metal. Well, we only have one equation that has heat capacity in it. We're going to use the equation Q equals mc delta T. And we can do that because remember before we asked ourselves, is it changing phases or is it changing temperature? And both our water and our metal are going to change temperature because the water is going to pick up the heat and get warmer. The metal is going to release the heat and get colder. And so what we find is that the mc delta T for the metal, okay, remember that's going to be negative because it's losing heat, is going to equal the mc delta T for the water. So remember, we needed to ask ourselves what's gaining, what's losing heat, what kind of heat is it gaining, what kind of heat is it losing. So we're substituting in. Now we know the heat capacity of water. Okay, that was that number we were supposed to know. That's 4186. Okay, when we find our change in temperature, your change in temperature, whenever you find a change in anything, it's always your final minus your initial. The last shall be first and the first shall be last. So we're always going to take our final temperature and subtract our initial temperature. We are going to know, at the end, okay, in our calorimeter we have our water and we have our chunk of metal. That heat is going to flow until the piece of metal comes into thermal equilibrium with the water, and so the final temperature of the water and the metal is the same. Final temperature of the water equals final temperature of the water. Okay, so our final temperatures for both the water and the metal are going to be the same number. The initial temperature of the metal we got from the boiling water because the piece of metal was in thermal equilibrium with the boiling water, and the initial temperature of the water was what it was, in the calorimeter before we started, before we stuck that hot piece of metal in there. And so what we're going to do is we're going to solve for this heat capacity. We're looking for the heat capacity of the metal. So you should find this answer is in the hundreds. So it should be anywhere from 200 to about 1,000. It shouldn't be much bigger than that. Okay, so the specific heat capacity, different materials have different heat capacities. We already know that water is 4186. And different metals have different heat capacities also. There's a list of them on the haiku page. So you're going to find the heat capacity of your metal. And you are also going to find the density of your metal. You remember how to find density? That's your mass divided by your volume. And your pieces of metal are little cylinders. So think about, how do you find the volume of a cylinder? Think about that. Look that up. I'm not going to tell you, haha. Okay, Google it. So you're going to find your volume of your cylinder, the mass of your cylinder. You can find the density of it. And you can use these two things to identify your metal. And that's going to be your task for the day.